Time travel per se is something that we do all the time. You're traveling in time, I'm traveling in time. So first step is we all move forward in time. That's very boring. That's not what you want to hit.
In special relativity, just like in Isaac Newton's theory of absolute space and time, you can travel to the future, but that's all you can do. You can never travel to the past.
The second layer of the cake is that there is time. You can travel through time in some sense at different rates because of the motion and because of gravity. Some people can experience the time between events as being different amounts.
But you're still traveling to the future, and that's it. But then general relativity comes along. Space and time are curved, and you can imagine that it's still true. You have to travel to the future, but the future can loop back on itself. So that just like if I were on the surface of a sphere, I could walk in a straight line, and I would eventually come back to where I started, even though I was just walking in a straight line. Einstein, in general relativity, says time can be like that. Space and time can be warped in on each other so badly that all you're doing is moving forward in time, but nevertheless you move in the right direction in space, and you find yourself meeting your previous self.
Are there ways of twisting things so that somebody can actually be going into the past, even though from their perspective perhaps it's their current future, but it's the past in terms of revisiting old events? And can we really do that using relativity, etc.?
This is something that in general relativity is conceivable, but we don't know if it's possible. We don't actually know that in the real world you can warp space and time enough to make it possible to travel back and meet yourself in the past.
A lot of this has to do with finding sources of energy that are powerful enough in a small enough space to warp space-time enough to really make a mess of time and perhaps allow us to go back. And really the only place we know of that we sure exists out there that is in principle powerful enough to do that are black holes.
A black hole is just what happens when gravity becomes so strong that it warps the space and time around it, so that going to the future is equivalent to going towards the center of the black hole. In other words, it's a region of space that once you go in, you can never come out. We have excellent evidence in the real world that the black holes exist in the Milky Way, in our Milky Way galaxy. We can see the emissions of things that are falling into the black holes, even if we can't see the black holes themselves. Now, what happens if you fall into a black hole is a bit of a mystery. We think you die. We think that's the end of it. You're torn to pieces by these tremendously strong gravitational fields, and then you crash into a singularity, and that's the end of you.
Moving into the past requires a suspension or a change in the laws of physics as we understand it.
Perhaps the right kind of black hole doing the right sort of thing could do that for us.
When space-time becomes warped by a black hole, part of it is that you're pulled toward the center. But if a black hole is also spinning, part of it is that you're pulled around the black hole into a circle, and that warps space and time in a different way. However, it's still not possible to travel to the past using a conventional garden variety black hole like we think you'd find at the center of our galaxy or in a star. But people have come up with exotic kinds of black holes, where you go to the center and the singularity, this point of infinite curvature and density, where everything is crunched down to a point. In a curving black hole, in a spinning one with a rapid rotation, instead of that singularity being a point, it's a ring. It's a loop in space. And if you're careful, instead of hitting it and dying, you can pass through the middle of it. You can go through the ring into a completely different region of space. And if the equations are right, and we haven't missed anything important, once you're in that other region, you can use that to travel back into the past of that region.
Those black holes are really, really huge and have a lot of their energy in a very large space, you see. So the problem there is that they won't locally bend time enough for us. One of my favorite scenarios for doing time travel is to exploit Einstein's relativity in making wormholes.
A wormhole is just basically like a tunnel through space that lets you take, in principle, a shortcut. So a wormhole would be a little region here where you could go in, and what would happen is it would be connected to this region over here. The distance that you would travel by going through the wormhole can be much, much less than the distance that you travel going outside the wormhole. So one other way to possibly draw it would be to imagine folding the sheet of paper. Here I am, and the wormhole connects me like this. A wormhole gets me there faster. Now you can imagine playing this exact same game, drawing exactly same pictures, except instead of just drawing space, I draw space and time. And what would happen then is, I would not only take a shortcut through space, but if this is space and time, so this is time going upwards, here I am, and I could have a wormhole that takes me to a place in the past.
So if you can build a wormhole, which is a huge if, in principle might be able to turn to a time machine by taking one of the doorways on a long trip and then use the effects of relativity. Now, the game you play is you imagine you could take the two doorways and you put one doorway on a spacecraft. You fly it off to Alpha Centauri or a long, long way away, and you bring it back, and from the Earth's point of view, it's aged, say, 8 years, but from its point of view, it's aged 4 days, which means the time differential between the two doorways is 8 years minus 4 days. So if you go in one doorway, that's the doorway that's 8 years in the Earth's future, you'll emerge in the other doorway 8 years and minus 4 days in the past. And so therefore, if you step through it, you go back in time.
We don't know if that's possible. These are things that we can write down the equations to describe them, we can draw the pictures. It's a sensible story, but we don't know if it's a true story. We don't understand the laws of physics well enough yet to say that.
There are lots of theories that enable the production of wormholes. The production of stable wormholes is much, much more difficult. Merely dropping a single electron into a wormhole will cause it to collapse and pinch off and kill whatever's going through. So it's not just making a wormhole, it's making a stable one.
And unfortunately, that seems always to tell us you need very exotic kinds of matter that we don't think really exists in this universe, and also a lot of energy, because that bending of the space-time requires literally ripping a hole in space-time and then sort of gluing it to another hole and making that tunnel. And that's energetically a very expensive thing to do.
You need to keep pushing the wormhole open. You use some sort of gravitational repulsive force to keep it just from collapsing. Remember, it's like a tube through space. It's like a tunnel underground, and that tunnel wants to collapse. There's forces that don't want to keep it open. So you need to balance those forces. The only way we know how to do that is with some sort of negative energy, some sort of exotic matter.
The problem is that we have no means of really making them using our understanding of the kind of materials we have around today.
What's important to emphasize is that this whole thing, this traveling through time, traveling through space, is very down to earth from your point of view. If you were really to travel through time, it would not be that you hop in some machine and wheels turn around and lights flash and there's a puff of smoke. It would be that you travel through space. You hop in a rocket ship or in a very fast car, and you move through space, and according to you, there's no bright flashes of lights, there's just the evolution of time.
One of the things we're finding in a lot of these physics scenarios, trying to see how time machines work, is that there are constraints on the kinds of things you can do once you've made a time machine. And a lot of them make a lot of sense. So one of them, for example, is if you make a time machine, by whatever method you use, you can't use that time machine to send things back to the past so far that it would have been before that time machine was created. And so you can build the time machine and it sits there for 50 years, and then 50 years from now you can come back to as early as when that time machine was, but not before.
That's the great thing about physics, is that forgetting about the actual technological resources you have, the laws of physics put constraints on what is feasible. So right now, even if we had infinite technological capability, we don't know how you could set about building a time machine.